Hello! Do you know who this guy is? It's Elon Musk, this quirky, crazy personality with some very interesting ideas. Among other things, Elon here has been heavily involved in getting humanity out into space with his SpaceX company. SpaceX has achieved some amazing things, like developing rockets that are reusable and that land after sending some spaceship out into space. How cool is that? And another of SpaceX's missions is to send people out into space, with the goal of making humanity interplanetary. That means one of SpaceX's missions is to have humans live on other planets, out there in space. It could be Mars over here, or one of those planets that Kepler found, that we explored earlier. If we're going to be sending missions to our Kepler exoplanets, SpaceX is one great partner that might be able to help us out. As the first step of our partnership with SpaceX, what we're going to be doing is taking missions that SpaceX has already launched using its rockets and populating our historical list of launches. Our historical list will now include the launches we've scheduled from our space launch dashboard here, but also those launched by SpaceX all the way back to the year 2006. One thing that almost every API does is that it talks to other APIs. It puts the data from those other APIs together to accomplish something new. APIs are, after all, reusable, just like packages and modules. In this section, we'll use the SpaceX API to demonstrate how to work with REST APIs that have already been built by others to create something new. Let's get into it. Welcome back. How are we going to get the SpaceX data? We're lucky. There's this really well-made unofficial API for data on SpaceX launches, rockets, and all kinds of other data. We're going to query this API from Node to find the data we need about our SpaceX launches. We're then going to track this information in our database. Of course, I'll attach the GitHub link for this API to the video, so you can follow along as we explore it. And that's exactly what we're going to do. The first step in using any API is exploring it and figuring out what data it contains and how it organizes that data. We then need to figure out how we're going to piece everything together, everything from that API, to get the data that's relevant to us. So what is it that we want to do? We want to get the list of all the launches that were ever made by SpaceX. And we know that our API is RESTful. So there's a very good chance that it contains a collection of SpaceX launches. If we scroll down, we have this usage section with an example request. We can see that the API is available at api.spacexdata.com and that our interactions with it are encrypted using the HTTP secure protocol. The API is versioned, and as of this video, it's at version 4. When you see a version string like this as the first part of the route of your endpoint, that means that any route that you add after it falls under version 4 of the API that you're querying. This way, if you want to upgrade your API and change how things work, you can keep the old version around under version 3 or version 2 so that existing users can still use that version of the API and migrate to the latest version when they have the chance to do so. This is always a good idea when you release your API to the public to be used by many different applications, which may not all be updated at the same time. We're lucky. The NASA API that we're building has only one client, the NASA Mission Control Dashboard. If we were to release our API to the public in production form to be used by many different applications, it would be a wise idea to start versioning our API so that if we change things, each client can update to the latest version on their own schedule. Let's find out how we might version our API in the next video, and we'll get back to our SpaceX launches in just a bit. I'll see you soon. How do you version an API? All this means is grouping together all the routes in your API under a version path and keeping old versions of your routes around after you've added a new version. You may choose to deprecate support for a particular version of your API, which just means telling users that you may stop supporting it at some point in the near future. But versioning allows you to gradually move all the users who are using your API to a newer version, because you still support the old version for some time after you upgrade. As API authors, we want to avoid forcing our users to update all at once, potentially breaking things in their application as they rush to do so. The simplest possible way for us to version our API would be by just prefixing our routes here with a version number. So say version 1 of our API for planets and version 1 for launches. And of course, for our index.html, with our front-end application, we want that to be served under the root, because it's only the API and the routes under it that we're trying to version. Our front-end and index.html, along with any of our assets required for that front-end, will still be available under the root route of our website. So this approach works. But say we wanted to organize things a little bit better, so that we don't have to prefix all of our routes with the version number individually. We could put all of our version 1 routes under an individual express router and create a new router for each version of the API. What would this look like? We can, for example, create a new file under our routes folder, and we can call it version1.js or whatever we'd like. But because this is the only version of our API currently, I'll just call it api.js. Now in our api.js, we can move over all of the routes that we've defined in app.js. So I'll move that over and paste it into api.js. And of course, we need to import those two router files. So I'll take that from app.js and move it into API. Now, we don't have an app object here, so I'm going to import express, const express equals require express. And with express in the module, I can now create a router that captures version 1 of our API. So I'll call it const API equals express.router. And remember how we use express routers? We can just add all of the routes and middleware for that router by calling the use function. So I'll replace app with API and export API from our module. So module.exports is just API directly. I can't forget to update the routes here. So we're now in the routes folder with our API.js file, which means I can remove the routes part from our paths. And our API file for version 1 is complete. But the reason why I've added a router is so that we don't need to prefix all of our routes with the version. Instead, we can prefix this router when we import it in app.js. Let's see what that looks like. I'm going to remove the version from our two routes here. And now in app.js, where I previously had the routers for the two collections, the launches and planets, I'll instead add the API router. So const API equals require from our routes folder the API.js file. Now I can add the API as middleware to our server's middleware chain here by calling app.use on the router exported from our API module. So app.use API, and it's version 1 of the API. So we're going to mount it. We're going to add it under this /v1 path so that now all of our routes, like those for the launches collection, are going to be under v1/launches and are then handled by our launches router. Now, if we wanted to add version 2 of our API, well, we could create another router and mount it under, say, app.use/v2, passing in whatever the v2 router was. This allows us to support multiple versions of our API at the same time. But for now, we only have one version, so I'll remove v2. Now that our API is versioned, we need to make sure that we're using the correct API endpoints when we make our requests in Postman. So when we get the launches, as long as we have our server running in the background, if we update the path here to localhost/v1/launches and save that, we should get back our response with whatever launches we've saved in our database. There we go, 200, okay. And we'll need to update all of our endpoints in Postman. v1/launches for our post, v1 for our delete, and v1 for our planets. With our Postman updated, we can't forget to update our front-end application. So in our client, under source/hooks/requests, where we make our API requests, we now need to update the URL of our API to /version1, and our requests will now go to localhost on port 8000 /version1/planets, or launches, or whatever our route is. We have some bookkeeping to do because we've updated our API routes, but the versioned API will now save us some work if we want to make breaking changes to our API without breaking our front end. It's a little bit more work now for much less headache later on. All right, since we've updated our front end here, we need to, in our console, run npm run deploy so that our front end code builds and is deployed in our server's public folder. So let's wait for that to complete. And when the front end is built and our back end is running, we can double check that everything's still working in our browser. Our site is on localhost at port 8000. We can get the full list of planets back from our API and schedule a new launch. I'll see you in the next video. Welcome back. Here's a really quick one. When we update our API to use versioned URLs, we need to make sure to update our API tests to use those updated paths for each of our requests. So every time we post to /launches, we now need to post to /v1/launches. In our success case, in our error case, our other error case, and at the top, when we get our launches as well. Now we can safely go into our server folder and run npm test, and our tests all pass. Very nice. I'll see you in the next video. Welcome back. We were exploring the SpaceX API. This RESTful API that includes data about SpaceX launches, rockets, and all kinds of other data. We want to use this API to get the list of all SpaceX launches. And if we scroll down, we were taking a look at this sample request, where we get some data from our SpaceX API using version 4, and a big thanks to the developers of this API for following best practices in versioning. And here's the fun bit. Our sample request already talks to the launches collection, passing in this additional path here to /latest. This is something that you might see in some REST APIs, where the launch that you're getting from the launches collection is being identified by some word, some label that's not a numerical ID. This still follows the REST practices. We're talking to our launches collection and getting a specific launch that's labeled latest. Let's make this request in Postman. I'm going to copy the URL, and in Postman, I'll make a GET request to see what comes back. There we go. We're already making requests against our SpaceX data. And what we've gotten back is this object that represents the most recent launch. We can scroll through this data, and we can see that, for example, this launch was a success, and that it was part of a batch of Starlink satellites. We'll explore our launches data in just a second, but what we want is the list of all launches and not just the latest. So what happens if we remove this latest label and send that request to the SpaceX API? We've gotten a response, and now you can see that instead of just returning an object, we now have an array of all of these launch objects for all of the SpaceX launches that have happened to this date. You can tell there's a lot of data. But we're getting our launches. So is that it? Are we done? Well, not quite yet. If we scroll back up to the top of our list of launches here, and we look at the data that's being stored for each launch, let's see, we have a few different pieces of data that are being returned. We have something called fairings and links. Let's scroll down a little bit. We have the success field, which matches up perfectly with the success field that we track in our API and in our database. So this is great. We can map this success field in our SpaceX API with the success field in our list of launches in our database. But here's the catch. For certain types of data, like the rocket data over here, or the payloads, our API isn't returning a useful object, but instead, this identifier, what the SpaceX API is doing, is similar to what relational databases do. Instead of including all the possible data for a launch in the launches collection, it's referencing objects in these other collections. For example, a collection of rockets that contains part of the data relevant to this launch. The intention is that we'll look up the data in the rockets collection with this ID if we want to get the relevant rocket information. In this case, it probably tells us which type of rocket was used for this launch. By returning an ID which references another collection, the SpaceX Data API is decreasing the size of the response that it needs to send back, which is a good performance optimization. Unfortunately for us, the rocket and its name is part of the information that we need for our mission control dashboard. We need to keep exploring. Our journey continues. Let's find out how to get all the data we need in the next video. I'll see you soon. Welcome back. We've discovered that the launches collection in our SpaceX API doesn't include all of the data that we need. We need to keep digging. The good news is, our API has some documentation that will help us figure out how it works. If I scroll down on this page, we can see that the developers have included a Postman collection for their API. This is a big bonus. It means that we can now use these requests in the Postman collection instead of creating all of the requests in Postman ourselves. Oftentimes, tools like Postman are some of the best kinds of documentation for your API. They provide samples of how to talk to all of the routes in your API. So we'll check this out in just a second. Let's see what else we have. We have our base URL here, which we've already explored. Our API has authentication, which is required for all destructive routes. So anything that changes the SpaceX data, well, that needs extra permissions so that not just everyone can go ahead and create new launches or delete the data that's stored for existing launches. We'll learn about authentication later in the course. Let's move on. We also have pagination and custom queries. Let's see what this is all about. There's an additional guide that we can explore. And we can already see that the developers of this API are using MongoDB and Mongoose. This is pretty neat. They've made some very similar decisions to those that we made. As you can see, the combination of MongoDB and Mongoose isn't that rare. Alright, other than the technology choices of the SpaceX API developers, we can see that there's these query routes that accept a query and some options. And if we scroll down, we can see that there's the option for pagination, which defaults to true. We'll get into pagination in another video. For now, we also have this populate option, which includes a list of the paths which should be populated with other documents. This is what we want. let's take a look at how we can use this populate feature over here to get all the data that we need. We'll do this by going back and installing that Postman collection that's available for us here. If I click on this link, which I'll also attach to this video, let's see. Postman loads, and then we have the option to run the collection in Postman for the web, or if we have it installed on our machine as an application. Both options work, but I'll select the application option here because I have Postman installed on my computer, and I'll open the collection in Postman. And if everything goes well, you can see that the SpaceX API version 4 collection with 74 requests was imported into my Postman. Let me close this old request. And if we scroll through all of the requests in our Postman collection, we can see we have the ability to get launch data, rocket data, payloads, and data specific to the Starlink satellites, as well as all kinds of other things. What we're interested in, primarily, is the launches. And the first request here is getting all the launches, which we've already tried. That's the v4/launches endpoint. But right below, we have query launches. This is a bit strange. Take a look at this with me. We have a post request, which we're planning to use to get the launches data that we need. A post request to get the data about our launches. This is a pattern that you'll sometimes see. When you're doing more than a basic GET request, and you want to pass in more parameters and options to be more specific in what data you're hoping to get back. With this pattern, we pass in our search parameters inside the body of our query request, which lets us pass in more data than, say, a GET request with some parameter, with some ID, as the only thing that the server uses to find your launch. So rather than relying on a single ID, if we use a post request with a body as a query, we can pass in more complex queries that specify which kinds of launches we want to see and what data we want to include for each launch. Technically, such query or search endpoints aren't strictly part of the REST pattern because we're using a post request, again, to get data. The HTTP verb doesn't match up, but GET requests don't allow you to pass data in the body of the request. So instead, some APIs use POST for search queries, where the server needs some extra information to respond to your query appropriately. While this isn't strictly by the book, it's a reasonable use case for POST requests. Just because we're not following the REST guidelines in this single case doesn't mean we should just throw away all of the other REST practices. This is a reasonable exception. So how does this query endpoint work? Well, if we pass nothing in the body, it should just return the list of SpaceX launches, just like we can see in our response. Except this time, under this docs property in the response, which now has an array of these launch objects. But we now have some extra capabilities. Say we wanted to populate that rockets property that we saw earlier. This one right here. It's referring to some data in the rockets collection that we can find down in our Postman collection. So what we could do is we could take this ID, and in our rockets collection, we could get one rocket, making a GET request to v4/rockets/ and then passing in that ID. So let's make this request, and in the response, we're getting all of this rocket data. How heavy it is, and what payloads that rocket was carrying, how many engines the rocket had, and some more specific information about them. This is all data that is tied to the launch that we were just looking at. But it lives inside of this rockets collection. So what if we wanted to populate this rockets data here inside of the response to our launches query? We could go up into our body and add our JSON data with our search query, which includes two main properties, which we saw earlier were query, which we can pass in as an object if we want to search for particular launches matching some criteria, some query. Say all of the launches after a certain date. But that doesn't interest us because we want all of the launches. We just want extra data populated on each launch object, which means we're interested in this second property here, the options. The options also take the form of an object, and the most powerful option here that we want to use is populate. We set the populate property to the list of paths inside of each launch object that we want to populate. So what does this look like? In our response, say we wanted to populate that rocket. Well, the rocket is under the rocket path of each launch object here. So all we have to do is pass in the string matching that path. So rocket. And now if I make this query and scroll down into the request, we should expect to see that rocket data. Check it out. The data that we saw when we queried the rockets collection. Very nice. But we can do even better because we're not interested in all of the rocket data. We really only care about, if we scroll down here, the rocket name. That's what we need for our NASA dashboard. We can actually filter out only the name from our rocket data by doing as follows. Rather than passing in the rocket as a string, we pass in an object here, and we'll say that the path is equal to rocket. So this query will give us the exact same response we just saw. But now we can also say that we want to select only certain properties from that rocket. So we pass in another object with the name set as 1 to signal that the name is the field that we want populated. Let's make this request and see if it's doing what we want. Let me scroll down. And now our rocket is getting the ID, so we can gather the rest of the data if we're interested. But other than that, we're just getting that one name property. Now that we know how to query our launches collection to get specific data, let's put this to use in our Node API. I'll see you in the next video. Welcome back. We now have a general idea of how we can query our SpaceX Data API to get the information that we need. What we now want is to populate our database with the historical data that we fetch from that SpaceX API. How might we do this? We'll be following a similar flow to how we load our habitable planets data. What we know is that when we start our server, we want to make sure that not only is our planets data loaded based on the information that the Kepler Space Telescope gathered, but also that our SpaceX launch data is available as well. So it's safe to say that when we start our server, we want to await some load launches or load launch data function. Where will this function come from? Well, just like the planet's data comes from the planet's model, we'll be getting our launch data from our launch model. So what we'll say is const load launch data equals require, passing in the path, so models/launches.model. After all, it's our models which work with the data that we're storing and make that data available to our controllers and send it back to the view, to the front-end client. So this is how we're going to start. Inside of our models, we'll go to launches.model.js, and right here near the top, say underneath the save launch call, we'll make an async function, load launches data. And that's data, where for now we'll just console.log that we are downloading launch data from our SpaceX API. And before we forget, let's export that function from our module. Because our function is at the top of our file, we'll keep it at the top of our imports. And let's see here. How are we going to make the request against the SpaceX Data API? We're going to use a third-party package that we saw earlier in the course. In our terminal, I'm going to npm install the Axios library. This really well-made and widely used Node package for making HTTP requests. Remember way back when we used Axios to make a request against Google's servers? When we duplicated most of our browser functionality, with the exception of, well, rendering the HTML that we got back? We used Axios because it provided a promise-based method for making HTTP requests. And it works in both the browser as well as Node.js. So how are we going to use Axios this time? Don't worry if you don't remember what we did last time. We'll be going over everything that we need right now. We'll start by installing our package. Once that's complete, at the top of our model, we're going to require our third-party package. Const Axios equals require Axios. Now we can use Axios inside of our load launches data function. And what we'll do is to make a post request, we're going to await the promise returned by Axios.post. This takes two main arguments. The first is some URL, and the second is the data that we're passing in the body of our post request. Let's start with that URL. I'm going to define right above our function a constant for our SpaceX API URL. That's going to equal the URL we were using in Postman. HTTPS api.spacexdata.com/v4/launches/query. So I'll take that and assign that to our API URL, which we can now pass in as the first argument to our Axios post function. And the second argument here is going to be our request body, which contains the query and options that defines which launches data we're going to get back from that API. We can start by taking the query that we used to get the rocket data and populate our launches with that rocket name. After all, we know that the rocket is one of the fields that we'll need access to so that we can display it on our front end. So let's copy that and paste it as the second parameter in our post request. What we've pasted is proper JSON with double quotes, so I'll clean up those quotes so that we follow the same convention that we're using in the rest of our program here. Also making sure to use single quotes for our string values. Consistency with the rest of the code is what we're going for right now. Looking good. Now, we've mentioned a few times that the rocket data will be required. But what is the full set of data that we need to fetch from our SpaceX Data API? If we scroll up to our sample launch, we can see that rocket is required. So we have that. I'll mark it as exists in our API. And specifically, it exists in our response under each launch under rocket.name. So let's just mark that in our comment here. We'll say that this corresponds to rocket.name in the response to our API request. What about flight number? Let's see. Do we have anything like flight number in our list of data here? Oh, there we go. Flight underscore number, and it's being set to a number. Looks like we can use this as the value for flight number in our database. So we'll keep marking each of our corresponding values so that it's easier to map them once we get the response to our post request here. And also, so that we know that we're actually getting all of the data that we need from the API. For the mission, we need a mission name. So let's see here. Looks like the mission name corresponds to this name property on each launch object. So mission is equal to name in our launch response. And for launch date, we're looking for something that we can make a JavaScript date object out of, some string value that corresponds to the date of that launch. Let's see. We have 3 possible date values in different formats. All of these values would probably work, but let's go with the local date in the time zone of the area where the launch occurred. If we had to choose, that's the value that seems to give the best information. So we'll map our launch date to date underscore local, marking that over here. For the target, well, unfortunately, none of SpaceX's existing launches have been targeting any of our Kepler exoplanets. So this is going to be a new feature in our space launch system. There's no applicable value that we could get from SpaceX. At least not yet. So we'll just say not applicable. What about the upcoming and success Boolean flags? Let's see. Right away, I see upcoming matches exactly. it's a Boolean value that tells us whether this launch has occurred yet or not. And let's see about success. There's our success value, which also maps perfectly to our API. So let's mark those. We'll say upcoming is equal to upcoming, and success is success. Very simple. Now, I've saved the best for last here. How do we get the list of customers that were working with SpaceX on this launch? Customers who usually want to send some sort of payload out into space using SpaceX rockets. Let's look in our API response. Starting at the top of our launch, we have fairings, links, we have our rocket, and that's the end of our launch, and there's no customers field. But you might have noticed, above the name and flight number, we have this payloads array. Let's do a search in the payloads collection using this ID and see what data we get back. There's our payloads collection, and we can get one payload by passing in the ID right here. Let's see what happens. We've got back this object, which includes the payload's name, that it was a satellite, and then this list of customers that were responsible for sending this specific satellite on the rocket, on the launch that we were just looking at. In this case, it was DARPA, this military agency from the United States. It makes sense that our customers array is associated with a payload because these customers are really just paying for some object or some people to make it out into space using SpaceX as sort of a transport service. What we have to keep in mind here is that each of our launches, if I go back to our launch request, can contain multiple payloads, which each have multiple customers. So we're going to need to handle that in some way. For now, what I'll mark in our API, in our comments here, is that customers comes from payload.customers for each payload. All right, there we have it. We now know where all of our data will be coming from. The only data that we're missing from our request here is the payload data that will give us our customers array. Because right now, that payload data is just a reference to a payload and not the actual payload data. So what we're going to do is we'll add another field or another path to our populate array here. So I'll say that we want another path populated, which is the path for the payloads that are being sent in that launch. And the value that we want to select is going to be the customer's value with our list of customers. So we'll set that to 1 to make sure that value comes in the response. The response from this Axios post request that we'll assign to, say, a constant we'll call response. There we have it. We're finally requesting the data that we need from the SpaceX Data API. Let's find out how to use the response to populate our database in the next video. For now, let's take a well-deserved break, and I'll see you very soon. Welcome back. With the code we've written so far, we've verified that the SpaceX Data API contains all the data for launches that we require in our mission control dashboard. And we expect that that data is coming back in the response to our post request, which is querying the launches collection. With this response object coming in, we now need to take the data as it comes back and map it to a launch object like we have near the top of our file. Let's use this mapping that we came up with in the previous video. What we're going to start with is right here below our response, we're going to create this launch data constant that will assign to the response, and taking the data property from that response, which is where Axios puts the body of the response from the server. So launch data is now the data coming in from the body of our response. And if we remember our postman request, when we use the query endpoint, the result came in this docs array. So in our code, let's fetch this array that's coming back from our query by saying response.data.docs. Now what we'll do is, keeping it simple, we'll create a for loop that goes over each launch in our launch data. So we'll say for const launch of launch data. You know what? Before we move on, I'm going to rename some of our variables because we're going to have a lot of different variables related to launches. So I'm going to be very explicit about what each variable is. I'm going to call this response.data.docs array launch docs, which is what we're going to be iterating through in our for loop here. And each item is going to be simply a launch doc. Now, inside of our loop, our goal will be to convert this launch doc as it comes back from our response into a launch object that can be saved into our database. So I'm going to build up this const launch variable, which takes the format that we expect with the flight number property, for example, mapping to the launch doc property, which is called flight_number. Right? That's the mapping that we had when we explored the API. The flight number maps to flight_number. And let's continue on, mapping our mission and our rocket, and so on. So I'll set the launch mission first to be equal to the launch doc name property. The rocket will be the launch doc first under the rocket object, taking the name property from that embedded rocket object. For the launch date, we agreed that we would use the date local property from the launch doc. So date_local. And we had upcoming and success both map to the identical property names in our launch doc, in that object that represents a launch in the SpaceX API. So upcoming maps to launch doc upcoming, and success maps to launch doc at success. What's the one thing we're missing? That's right. Again, the customers array is going to be a special case. Why? Because our customers array will be the combined list of all of the customers for all of the payloads. Basically, what we want is to combine all of the values in an array of arrays into a single array. Whoa, what does that mean? Let's take it step by step. First, we know that we need to grab the payloads from our response because each payload has some customers. So right here above our new launch object, I'm going to set payloads to be the payloads property from our launch doc. So launch doc at payloads. And now we need to get the customers, so const customers, from this list of payloads. We're going to make use of a very powerful built-in JavaScript function that you may not have heard of. I'm talking about this flat map function that we can find on my favorite site, the Mozilla developer documentation. If we scroll down, we can see that this function works on an array and flattens it by calling this callback function on every item in that array. That might not seem fully clear yet, so let's look at an example in our node REPL. Say we had a function that we called duplicate, and it takes some number that we'll call n and returns that number in an array with a copy of itself. So it takes a number and duplicates it, returning the array with both copies of that number. If we had an array of numbers, say 1 and 2, and we called flatMap, passing in the duplicate function, the value that we get back is the result of calling duplicate on each element, so 1 and 2, and flattening the result into a single list, a single array. So the result of this operation duplicates both 1 and 2, and then flattens the result into the single array 1, 1, 2, 2. We can use this approach to turn any array of arrays into a flat array like the one we have here. So let's see how this might apply to our customers and payloads. We're going to get our customers by calling flatMap on our payloads array. So payloads.flatMap. And what are we going to do in this callback function here? Basically, we know that each payload can have a customer's property with more than one customers. So to get all of the customers for all of the payloads, we're going to take each individual payload, and inside of our callback, we're just going to return that payload's customers. So payload at customers. That's it. Now those nested customers inside of the payload are going to be turned into a single customers list for this entire launch. The flatMap function helps us to turn all of these customers lists in our payloads into a single list for that launch. Now that we have our list of customers, we can add it to our launch by just saying customers is equal to customers, or using the shorthand and just saying customers. And we can test our code for now by logging using our template string, the launch.flight number, and the launch mission. Let's see if our code works by running npm run server. We're getting this error here. Notice telling us load launch data is not a function at start server in server.js. So we need to make sure that we're calling the correct function. In server.js, we're calling load launch data from our launches model, and we made the mistake here of exporting this function called load launches data. So I'll just go with the name in server.js and export load launch data, making sure to update both the function name and the export. All right, let's give that a go. We can see our launch data is being downloaded immediately after our habitable planets are found and loaded into our API. And we're only getting 10 launches here, when I'm absolutely positive that there's been more than 10 SpaceX launches to this date. It looks like not all of our launches are coming back in our query response. Let's keep digging so we can save all of the SpaceX launches for use by our NASA API. I'll see you in the next video. Welcome back. The data that we got back from our query response only includes the first 10 SpaceX launches that ever occurred. For example, we can see this early Falcon 9 rocket test flight. So what's happening? Why aren't we getting all of the launch data? The SpaceX data API that we're using is paginating the list of launches, and it's only returning the first page of data. We can guess from our response here that each page of data includes at most 10 launches. Pagination splits the data that we get from the server into different pages, just like in a book. Why is it paginating our response? Well, when our list of launches contains many launches, the response to our query could get very large. This is costly for the server to send back and forth to the client. Paginating the data saves the server some work and allows our application to load the page data much faster, because we're only returning some of the documents. How do we work with such paginated APIs? We'll find out in this video. Let's start by looking at our query here and duplicating it in Postman. We want to look into the API's response and how we can use it to work with the paginated data. If we remember our original query, we already tested that we could select the name from a rocket, so we're missing only this payloads path with the list of customers. So I'm going to copy this payloads object and move that into Postman, where we can add it to our populate array here. So I'll add a comma followed by this object over here, and I'll format it correctly. For Postman, we need to make sure we're passing in valid JSON with our double quotes around each of our properties, unlike in JavaScript. And this includes the payloads value here. All right, we're good to go. Let's see what the API responds with. We get the 200 response, and we have this collection of documents with our list of launches, And if I scroll through this all the way, at the bottom of the response, after this array, we can see a few properties that relate to how the data is paginated. We can see that there's a limit of 10 documents per page. There's 142 total launches in this list of documents that we could potentially query. But right now, we're only on page 1 of 15 total pages. And then we have some extra data that helps us navigate through these pages. So is there a previous page? No, we're on the first page, but there is a second page, and the next page is that second page. Sounds simple? All right, so how do we navigate from page to page? Well, in our options object, when we make our query, in addition to the populate field, paginated APIs always let us set the page that we want to view. In our case, we can set this page option and set it to a number that corresponds to the page. So if I select page 2, let's see what comes back. Scroll all the way up to the top, and let's see. We have this Falcon 9 rocket, but scrolling further down, we can see that it has flight number 11. And the next launch has flight number 12. So we could navigate through all the data by iterating through all of these pages, by making 15 requests to get all of our data back in response. But say this is too slow for us. Maybe instead of 10 documents per page, we want to load 20 documents all at once. Many paginated APIs let you set this limit or size parameter, which controls how large each page is, how many documents they contain. So let's say 20. And now if we go to page 5, which set of documents will that contain? Let's see. What is the first launch that comes back in our response? We have this Falcon Heavy rocket carrying one payload by the United States Air Force, another by NOAA in collaboration with NASA and the country of Taiwan. And there's even a third, wow, and fourth, and fifth, sixth, seventh, eighth. There's a lot of customers on this one launch. I wonder just what it was carrying. All right, but what are we interested in? That flight number for our first document is 81. So we've skipped ahead pretty far, but we'd still need to make many requests to our API, depending on how many launches there have been. You'll probably see a number much higher than 142, because this is live data. You'll get the most recent set of launches made by SpaceX. Here's the thing. For our mission control dashboard, we already know that we'll need all of the SpaceX data in our database. So what we can do is turn off pagination completely. To populate our own database, we'd need to go through all of these pages one way or another. So what we can do is, rather than selecting the page and limit, is to set this pagination option to false. Now, our response will take a bit longer to complete and will be much larger, definitely several hundred kilobytes, if not more, because it now contains all of our launch data. So let's update our request to pass in the option to turn pagination off, setting it to false, which means our API now gets all of the SpaceX launches, all with one request. I'll see you in the next video. Welcome back. we've turned off pagination and we're getting all of the SpaceX launches. But the request that we're making here is fairly costly. There might be many launches that are sent back from this URL, which means that the server behind this URL needs to do a lot of work transferring a lot of data back to us. This adds load not only to the SpaceX Data API, but also to our server every time it has to load that data. We want to be a good consumer of that API and only ever make one request the first time that we need to load our launch data. After that, it should already live inside our own database. There's a few ways that we can do this. One approach is before we download our launch data, to check if one of our SpaceX launches already exists in our database. For example, we can check that the very first flight here, this Falcon 1 rocket with flight number 1 and mission name Falcon Sat, if this first mission has already been saved to our launches database, then chances are that all of these launches have already been loaded, and we don't need to make that expensive request to the SpaceX API. Now, I know we haven't saved anything to our database yet. Right now, we're just logging the flight number and mission of each launch, but we'll get to that in the next video. For now, let's make sure that we're reducing the load on our SpaceX API and only downloading launch data that we don't already have. What we'll do is using our launches database, that Mongoose model, which has access to our launches collection in Mongo, and we'll add a function to our launches model here. We'll say async function, and what it'll do is it'll get or find launch that matches some criteria, some filter object that we can use when we query Mongo, just like we do when we search for a flight by the flight number. So this function will be a little bit more generic. What it'll do is return await launches database dot find, and we're only looking for one matching document that matches the object that we pass in the filter, in the parameter to our function. Just one line. And now we can actually clean up our code to avoid duplicating this find one call and have exists launch with ID return await our find launch function over here, passing in the flight number as the filter. So we'll just say return await find launch, making use of our generic find launch function, which we can now use to check if that first SpaceX launch already exists before we download launch data. So what we'll do is we'll await find launch, passing in the criteria matching the launch that we just looked at. So flight number will be 1. The rocket will be the Falcon 1 rocket. And the mission name, what was that again? It was Falcon Sat. So we'll copy that as the mission that we're looking for. And that's enough criteria for us to be fairly sure that this flight is coming from the SpaceX API. It's not going to be perfect, but in the majority of cases, we'll be running this load launch data function either with a completely blank database or with a fully populated database where this launch exists. So it's good enough for our purpose to save us from making this very expensive query unnecessarily. Now what I'll say is const first launch equals await find launch. And we'll just check if first launch with an H here already exists, then we'll log that the launch data was already loaded. And what we can do is return from our function. That should do what we're looking for. Now, our code here isn't the cleanest. This load launch data function is getting a little bit long and unwieldy. So what we can do as a start is move this piece where we download the launch data and eventually populate the database. I'll move this out into its own function. So I'll move that. And right above load launch data, we'll have an async function that I'll call populate database, or just populate launches. That's the final thing that we're trying to achieve in this function. I'll just paste the code from earlier. So this populate launches function will always make a request to the SpaceX API. And then down here, we'll populate launches collection. That'll be our to-do for the next video. But in our load launches data function, we can now say if the first launch exists, we'll log launch data already loaded with an exclamation mark. And we can now remove this return statement and only call populate launches in the else condition right here. Populate launches, which is async, so we await it. Just a little bit cleaner. Now, if we go to the terminal, we can see that our API is running. And look, we're getting all of these launches, including this Worldview Legion satellite, which is going to observe our beautiful planet and create 3D models of the surface. Its mission is to analyze how the Earth changes over time and what effects we humans have on our planet. Very cool. We also have many more where that came from. All of these launches are being downloaded because this first launch doesn't exist in our database. There's no reason why it should, because we're not actually saving this data to Mongo just yet. For that, I'll see you in the next video. It's going to be a good one. Welcome back. All that remains for us is to populate our launches collection. We've done all the hard work. We've mapped our launch object here, taking the launch properties as they live in Mongo and mapping them to the launch properties from our API response. To save this launch in our database, well, we can use the save launch function that we created earlier in this section. So what we'll do is we'll call save launch right after we log our data. We'll say await save launch, passing in the launch object that we build up. There's only one problem with this, and we can see what that is if we look in our terminal. We're getting this error that says, let's see, when we download our launch data, we're getting this no matching planets found at our save launch function. That's one of our errors. Remember what it meant? Let's see. In save launch, we throw the error that no matching planet was found when we try to create a launch with a target planet that doesn't exist in our planets collection. Why are we getting this error? Well, we're not passing in any planet in the launches that we get back from SpaceX. Remember when we mapped our API launch to this launch object, there was no target planet because all of the SpaceX launches up till now haven't been targeting any of the Kepler exoplanets. That's what our space launch system is built for. But that's okay. There's nothing actually stopping us from having launches with no target planet inside of MongoDB. If I go into our schema here in launches.mongo.js, if we scroll down to the target, the planet, we can mark this as not required by removing this required property. And when we save our launch, we'll remove the check for target planets. So we'll go down to where we save our launch, taking this validation check and not removing it completely, but instead we'll move it out of this function to allow our save launch function to basically save any launch, regardless of whether the target planet has been set or not. And instead, we'll move that check into our schedule new launch function. Because really, the requirement that a launch has a target planet only applies when we schedule a launch through our mission control dashboard, which calls this function. So it's just a matter of pasting that check above where we schedule a new launch. This is exactly the behavior that we're looking for. Let's see if our launches are being saved in Mongo. Our API is telling us that the launch data has already been loaded. So let's see what Postman comes back from our API. I'm going to go out of our SpaceX API and back into our NASA project to get all the launches. Check it out. We have this long list of launches coming back from our newly populated database. Just one more consideration before we call everything a success. If we go to our post request, where we call axios.post, there's a chance that the SpaceX API will return some status code other than 200. Maybe something in our query went wrong. So it's a good idea, below where we get our response, to validate the response status code, which we can do by saying if response, using the response object that we assign when we make that request, and say if response.status is not equal to 200, success, then we'll log that there was a problem. So problem launching or problem downloading launch data. And we can throw an error up into our controller to terminate this function. So we'll throw new error saying that the launch data download failed. Just like that. Now with our server running, we can explore our historical launches in our dashboard. Going up into our history page, we can finally see all those SpaceX launches starting from the year 2006. And we can explore all of the launch data, including the list of customers for each of these launches. How cool is that? I'll see you in the next video. Welcome back. we've learned that many REST APIs paginate their responses. In this video, we'll find out how to add pagination to our own API endpoints. To recap, we add pagination when we want to avoid sending too much data from our API, when less data is enough. For example, say I'm searching for Mount Fuji in Google. There's many millions of results that Google is aware of. But Google paginates the results and only gives me the topmost information, the most relevant information, on this first page of the results. On a site like Google, something like 95% of the traffic of the link clicks that Google generates comes from that first page. So it would be a waste to include hundreds or even thousands of results when much less is needed. Google still lets you navigate from page to page by clicking on these links or by navigating to the next page. But it's usually not necessary. Say we wanted to do this in our mission control dashboard to display our data organized into different pages. This could be particularly useful in the history page of our mission control dashboard, where hundreds of historical launches could accumulate. Maybe we only care to list 50 launches at any one time on the screen right here. So how do we split our response data, our launch data, into pages? When we make our request to get all of our launches from our API, to paginate those results, we need some way of passing in two main pieces of information. One is the page that we want to display, and the second is the size of each page, the amount of documents that each page will contain. Or, in other words, the limit on the number of items in each page. One of the most common ways of doing pagination is by passing in what's called the query parameter into our getRequest. This is used to pass in basic parameters into our getRequest for the launches without using a post request and using the body. Query parameters, which look something like adding a question mark followed by the name of a parameter and then setting the value of the parameter with an equal sign, so value. Notice that Postman automatically detects my query string here and adds it to this list of parameters, with the key being the param and the value being value. These parameters are used to narrow down the results that you get from a specific collection. As an example, going back to our pagination, if we wanted to limit the amount of results that come back from this response, we could pass in a limit parameter and assign it to, say, 50 launches to be returned at most. Now, if we had 140 launches, it would require 3 pages that each have 50 or less launches to respond with all of the data. So we could navigate from page to page by adding one more parameter with this and symbol and say that the page should be the first page, or the second, or the third. This is how we're going to do pagination. In our code, we have this getAllLaunches controller function that responds to that getRequest. We can have access to our query parameter by logging this request.query value. So in Postman, if I make this request, the response won't change because right now we're just ignoring our query parameters. But in my console, we can see that Express parsed the query string and our request.query object has the limit set to 50 as a string and the page set to 3. This is a great start. The last piece of the puzzle is going to be two functions that we use in our model function that responds to our request here. Going into our launches model, right now our getAllLaunches function finds all the documents in our database and filters out the ID and version properties from each document. Mongoose and MongoDB allow you to chain a .limit function onto your find. Just like we've discussed, this allows you to limit the amount of documents that come back from Mongo. So if we wanted to limit our launches response to 50 documents, we could do that by passing in the number 50 as our limit. Now, for the page, there's no direct function that we can use in MongoDB out of the box. But we have something very close. We're going to use this .skip function right before our limit, which skips over the first 10 documents if you pass in the number 10, or 20 if you pass in 20. In this case, we'll return the 50 documents after we've skipped the first 20. With just a little bit of math, we can turn this skip function, combined with our limit, into a reusable way of implementing pagination using purely built-in Mongo and MongoDB features. Let's find out how in the next video. I'm excited for this one. I'll see you soon. Welcome back. Let's paginate our getLaunches endpoint. Are you ready to do just a little bit of math? We're going to use the page and limit query parameters that are made available to us by Express in this request.query object to calculate the appropriate skip and limit values for us to pass in to our Mongoose model, which will paginate our results. So how do we go from these page and limit values to the appropriate skip and limit values? Remember, each page has at most limit documents in that page, and skip defines how many documents we're skipping over in the result from our database. It'll make more sense when we start putting this knowledge to use. So let's do it. We're going to start by adding a file to our services folder, the one that right now only has mongo.js. Inside our services folder, I'm going to create query.js. You see, we want to allow any endpoint to make use of our pagination logic. This query file will give us a reusable way of making any endpoint paginated. And the first endpoint we're going to paginate is our getAllLaunches endpoint. We'll start by getting the values that we want from our query object. So we can use our destructuring syntax, saying that const page and limit are coming from this request.query. We can remove this console.log now. And using this page and limit value, we're going to call a function in query.js which calculates the appropriate skip and limit values. Maybe I'm sounding like a broken record here, but that's really all there is to it. So inside of query.js, I'm going to define a function called getPagination, which will take the request query object and it's going to return those skip and limit values. How? Well, the limit is easy. Our limit value is basically 1-to-1. The only thing that we need to keep in mind is that the value that comes back from our controller in our request.query object is a string. So what we'll do is call this math.abs function, passing in the query.limit value. This math function returns the absolute value of a number. So if a number that you pass in is positive, it just returns that value back to you. And if it's negative, it returns the positive version of that number. And the neat little bonus for this function is that if you pass it a string, it will convert that string into a number as well. All right, what about the page? We're going to take that from our query as well, using the exact same method. So we're going to say math.abs query.page to make sure that we're getting the numerical version of the page, and to make sure that it's a positive value that's being passed in for both. We don't want the client playing tricks on us by asking for, say, a negative limit. That wouldn't make sense. So we have these two values that are coming in our query parameters. Now let's convert them into the values that we need, that skip and limit, which are going to be the values that we return from this function. And we can return them as an object. So what we're going to do is return skip and limit, using this shorthand syntax where skip is skip and limit is limit. All right, so all that remains, we already have the limit defined. So how do we define that skip value? We'll say const skip equals, the amount of documents that we want to skip if we're on a certain page. So if we're on page 1, we want to skip 0 documents because that's our first page. If we're on page 2, we want to skip the first limit documents. And if we're on page 3, we want to skip the first limit times 2 documents, right? Because limit represents the amount of documents in one page. So the formula here is page minus 1 times limit, right? So the first page is 1 minus 1, so 0 times our limit, say it's 50. So that will be skip being 0, whereas for page 2, 2 minus 1 is 1 times our limit, so 50. So for page 2, we're skipping the first 50 documents, and so on and so on. Our function is now calculating the correct amount of documents to skip for a given page. Now, why are we returning both skip and limit when the limit is basically just being converted into the numerical absolute value of whatever we pass in. Well, there's more to this function than that. We can also set defaults for both of these values, for the page as well as for the limit, in case they're not set when the client makes that request. We still want to accept a request that includes just one of these values, say like that, or none of the values. So trying to get all of the launches all at once. The way we can do this is by defining a default page limit and a default page number. So the default page number, that's easy. That can be 1. So we'll define 1 as the default page using this OR syntax and say that if this value here is not defined, then we'll use this value on the right, so 1 as the page number. And for the limit, we'll do the same thing. We'll say if the query limit is undefined or null, we'll say OR default page limit, which we can define at the top of our function. So const default page limit, which we can set to some value, say 50. But because we want to be able to make the request without any query parameters, if the limit value is not set, if it's null, we actually want to return all of the documents on the first page. So we want the page limit to be basically infinite. Luckily, in Mongo, if we pass in 0 as the page limit, Mongo will return all of the documents in the collection. So now when the query limit is not set, all of the documents will be returned on the first page. And we can clean this up and move the default page number to be defined above. Default page number is 1. Let's export our function from our module. So module.export is going to return an object with our getPagination function, which we can now import in our launches controller. We're going to take the getPagination function from the required module. So up out of our launches folder and out of our routes folder into this services folder with query.js. So services/query. Very nice. Now, we didn't quite get things right the first time. We need to shift things around here a little bit. What we're actually getting here is the skip and limit values by passing in request.query into our getPagination function. Just like that. Because our pagination function takes the query object and grabs the page and limit and calculates those two values. Which now means that our controller function can pass this skip and limit into our getAllLaunches function for it to pass those values down all the way into Mongo. So I'll pass in skip and limit as parameters into getAllLaunches, and let's move that into its own line just to be a little bit cleaner. So const launches is going to be the result of awaiting our getAllLaunches call, and we'll pass launches into our response. That's a little bit cleaner now. So all that remains is for us to use these two values inside of our model function here. Our getAllLaunches function calls find on the launches collection And we can chain these two values to get the correct page of data. So we're taking in skip and limit in that order, I believe. That's right, skip and limit. And we'll pass those values in directly into their corresponding functions. This looks great. Let's test our code. All right, we're getting one error here. Required is not defined in our launches controller, so I must have made a typo. Let's fix that and see if the rest of our code works. So far, so good. Let's make a request in Postman using a limit of, let's say, 5 launches. Let's keep the values small so it's easy to see if things are working. And we'll start with page 1. Let's see. We're not getting a response, so there must be an error in our console here. GetPagination is not a function in HTTP getAllLaunches. Okay. Let's check out our function here. GetPagination is being required from our query service. Is it being exported? It is, but we typoed here on module.exports. All right, good catch. Let's give this a third try. What does that first page look like? Things are working, and if we scroll down, we're getting 1, 2, 3, 4, and 5 launch documents in our response, just like we expect. However, if we look at the flight numbers, it's not quite the first 5 documents. Things are a little bit scrambled. There's flight number 105, 107, and 106 as the first 3 launches. And if we go to page 2, let's see what we get back. All right, page 2 includes flight number 1, 2, 3, and so on. Things aren't quite in exactly the right order, but our pagination does seem to be working. If we go to page 3, let's see. We're getting 5 new launches. Let's get to the bottom of what's happening on page 1 with our out-of-order launches in the next video. The next one's gonna fly by, so let's get into it. I'll see you soon. Welcome back. Why are our documents coming back out of order? Our first page of launches starts with the flight number 106. Maybe on your machine, you're getting a slightly different number. The reason is that Mongo doesn't order our documents here by the flight number by default. The flight number is something that we defined and we decided determines the order of the launches, but that's not something that Mongo understands. Unfortunately, when doing pagination, the order of our documents can matter significantly. Our users will expect each page to be more or less sequential. So one approach to solving this is to sort the result of our find operation before we return it. Luckily, this is very easy to do with Mongo. We can just chain another operation, like the sort function, and the documents that are returned are going to be in order. We can determine the order that the documents come back in by passing this object, which determines what value in our launch objects determines the order of those objects. For our case, it's the flight number. So our sort function takes this object, which will say flight number, can be either -1 or 1. -1 for descending values with the highest flight number first, and 1 for ascending values, which happens to be what we want. Naturally, we expect the first page to have the first flight, and higher pages will have more recent flights. With that change, let's see what our first page comes back with. Our first document is now that Falcon 1 flight that we expect. And going forward in our pages, page 2 should have the flight number starting from 6. That Falcon 9 test flight we mentioned earlier. Very good stuff. Now that we're satisfied with our launches model and we're pre-populating it with all of the SpaceX launches, we can now remove this example launch we created with our hard-coded values. We no longer need this because we're getting real-life data from SpaceX. So our launch can go, and our save launch function here as well. Now we're working with real-life data. This is what we wanted. Our Launches API can now support pagination and returns documents in the correct order. Our API is looking good. I'll see you in the next one. Welcome back. Our NASA API is demonstrating some very neat things. However, in the process of working on our API, it's very likely that we added some data that doesn't belong. For example, on my upcoming launches page here, we can see that flight number 100 matches that hard-coded example launch we previously had in our code. It seems to have overwritten the SpaceX launch with flight number 100. And it's also very possible that we have other data from our API tests that's also polluting our real-life data. This is normal during development. But if we want to demonstrate our API to the public or to NASA itself, we want to be showing real data. The best approach in this case is to clear out our development data and reload everything from the correct sources. Our server already has the ability to load the planets and launches data whenever it starts up. All we really need to do is create another database or clear out the collections in our existing database to get back to what we call a pristine state with clean data. With an empty database, these functions should repopulate all of our data. What we can do, for example, if we're using Mongo Atlas, is go into our database's collections and remove those collections. So clear out the launches and we can also clear out the planets as well. With an empty database, if we run our server again, I'll terminate it and restart, our planets and launches data will start populating our database, including, if we scroll up, the correct launch with flight number 100. Now, if we go to our mission control dashboard and refresh our page, we have a fresh set of data, including our historical SpaceX launches. All green here. I'll see you in the next one. Bye for now. Welcome back. In the upcoming section, we're going to talk about security and how it applies to our Node.js projects. But before we get there, there's something we should definitely do with our NASA project. Let's look back into our Mongo service. When we connect to our Mongo database, the connection string includes the name of the database as well as the password we're using to connect and read and write data to that database. Well, it's never a good idea to keep our secret values like passwords or API keys and even tokens. It's never a good idea to keep these secrets inside of our source code. We'll be talking about API keys and tokens and more details about managing our secrets when we talk about security and authentication. But long story short, keeping these values inside our source code makes it easier for them to be leaked, especially if we want to share our code with other developers. For example, using something like GitHub. If we want to share our code without necessarily giving access to our database, we need to remove these secrets from the code and store them more securely. As it stands, we're giving anyone we share our code with access to our Mongo database. If you want to share the NASA code we write in a public repository with a Mongo database attached, I highly suggest you follow the steps in this video. One way we can solve this problem is by using a package that's called .env. Let me demonstrate. I'm going to install this package in our server. So changing directory into server, I'll do npm install .env. What this package does is it takes the values from a file called .env that lives inside of our server folder now. So I'm going to create .env. And this file stores values that look like key equals value. And it then populates these values in the built-in process.env object, the one that represents our environment, the environment in which our server is currently running. So for example, we could set this port value by setting it in our .env by writing port equals 3000 or 5000, or we could just leave it at 8000. This value will now set which port the server runs on when we call the server.listen function. So notice that the port isn't necessarily a secret. There's other benefits to storing configuration separately from our source code. This makes it easy to populate different values if we're running our application, our source code, in different environments. For example, maybe a development environment is going to use port 3000, but a production environment will use port 8000. We can set that in different .env files depending on which environment we want to run our server in. All right, so what's any of this got to do with security and MongoDB? Well, in the same way we set our port, we can set this Mongo URL. I'm going to take the value here without the quotes, and I'm going to copy that, and I'm going to move it into this .env file. Underneath port, I'll set Mongo_URL to be this value. Now, in my mongo.js file, I can set the Mongo URL to be equal to whatever has been set by the .env package in the process.env object under the property that matches whatever we put in our .env. So Mongo_URL. All right. But hold on a second. For these values to be populated, we need to actually apply the changes using our .env package. We can do that in our server.js by calling the require function and importing the .env package. We're not going to set this to a constant because we'll just call the .config function directly on the module. This is the only function, the only property of the .env module that we're going to be taking advantage of. And what this does is exactly what we said. It populates our process.env object with the values in our environment file. And the reason why we call this function above any of our local imports here, these files that live inside our source code, is because we want the environment to be populated not just in our server.js, but also in all of these other files when we import them, especially this Mongo service. Now, here's the thing. If we're sharing our code on a service like GitHub, we want to make sure that our .env file here isn't being shared alongside our code. That was the whole point, to keep our configuration separate from our source code, and also to make sure that our secrets here, like our password, don't get leaked. So we can add this .env file into a gitignore file if we're using Git, to make sure that it's not included when we share our code in a Git repository. So I'll add .env, and we can actually see that we could have different .env values for local development, or a test environment, or even production. Remember, we copied this .gitignore file from the client, from the Create React App frontend. It came with all of these examples already included. But for our purposes, one .env is good enough. Right now, we only have one environment. All right, very nice. Our Mongo secrets no longer live in our source code. But hold on a second. What if we've already shared our source code, including the Mongo database password? No worries. This is good practice for how to react if you've somehow unintentionally leaked any secret from your code, from your project. Even with the best intentions, this sometimes happens. We'll find out how to secure secrets that have already been leaked in the next video. I'll see you there. Welcome back. We're in a little bit of a predicament here. we've realized that the code that we've shared on a service like GitHub included the password to our Mongo database. It's a good thing we found this now, before our database contained any private information. But what do we do now? There might be this temptation to try to go into our source code and somehow remove the password or any of the secrets that we've leaked from that source code. But that would be a mistake. Any of the secrets that you've published could potentially already have been leaked and saved by some malicious user just waiting for their opportunity to take advantage. At this point, it's a good idea to assume that your credentials are already compromised, that they're in the hands of someone who is going to try to break into your server. It might not be the case, but it's good to be prepared for this scenario. If our credentials have already been leaked, what we need to do is go into the service that those credentials are for example, MongoDB here, and remove all access that those credentials provide, replacing them with new credentials for your application. This is also known as rotating our credentials. In my Mongo Atlas dashboard here, I can go into Database Access under Security and remove this NASA API user that we've created by deleting it, or optionally just editing the user's password. But it's better to be certain that we're removing all previous credentials and replacing it with a new user. So I'll add a new database user. We can keep the username the same, so NASA-API, but this time we'll auto-generate a new secure password that hasn't been shared anywhere publicly. And we'll copy that, first going to the bottom of the page here to add this user with read and write access to our database. So I'll add the user. And when the changes deploy in Mongo Atlas, we can now go into the .env file and replace the database that we used earlier. That's the part here after the colon and before the @ symbol, and paste in the new password. We can test our changes by starting up our server and seeing if the Mongo database connects. If we get an error when we try to authenticate with MongoDB, this sometimes happens when we deploy new changes to our Atlas Mongo database. It's worth taking the password that you've newly generated and going back into Atlas and making sure it's been set on the NASA API user. We can go to the Edit Password option and paste that password in, making sure that it's the correct one, that new secure password, and just updating the user to make sure that the changes are applied correctly. This might take a few minutes, so grab a coffee, grab a drink of water, and when Atlas tells us that the changes have been deployed and the notification disappears, we can check our server's connection one more time. I'll clear the console and start that server. Mongo has successfully connected, and our secrets are now in a private .env file that's not shared anywhere publicly. Let's keep things that way going forward. All right, this was good practice for what happens when our credentials are leaked and we need to rotate any secrets or passwords that are used by our server. Good stuff. That's all for now, and I'll see you in the next one.